Okay, welcome to Bombala Math. So in this lesson, we're going to do factoring polynomials, but we're going to focus on just the difference of squares. So it's a special pattern that we're going to follow with this factoring technique. Notice that each one of these has two terms. They each have two terms. So what we're looking for with the factoring by using the difference of squares, you need to have a minus, first of all, because there's no such thing as the sum of squares. And both of these terms have to be perfect squares. What do I mean by perfect squares? The square root of 4 is 2, square root of 16 is 4, and so on. So both of these have to be perfect squares, and this needs to be a minus. If you don't have that, the best that you can do is maybe take out a common factor, and that's it. So you want to look for those. Again, the minus is the key. In order to have the difference of squares, it has to be a minus. There's no such thing as a sum of squares. And I know students want to do that, even though both the terms might be perfect squares, they see a plus, and then they try to go ahead and do some technique with that, and it's just not true. So going over the pattern, if you have the difference of squares, let's say you have a squared minus b squared, what's going to happen is that's going to factor to a minus b times a plus b every time with a difference of squares. So looking at number 1, first we want to actually check to see if we have a common factor. Because if you have a common factor, you want to go ahead and take that out first. We always want to do that. And in some cases, if you don't take out the common factor, you won't be able to simplify the problem. It's not going to work. So you always want to make sure you check to see if you have a common factor. So here we do not. We do not have a common factor. We do have a minus. And I'm going to say, all right, well, is 4x squared a perfect square? So if I go ahead and take the square root of 4x squared, I get 2x. So that's good. Then if I do the square root of 25, that is 5, so that's good as well. Now some students will say, well, how come you don't put the square root of negative 25? Because that's what you have here. Remember that this is the pattern, so the signs take care of themselves. So you're just checking the 4x squared, and you're just checking this number 25. But again, that's because of the pattern, the signs will take care of themselves, so you don't want to put a negative 25 in there. That would give you an imaginary number. And now what we do is separate it into the two parentheses. So it's this 2x plus 5, and then 2x minus 5. Any order doesn't matter. You could have 2x minus 5 times 2x plus 5. It doesn't make a difference. All right, so when we look at number 2, you see you got this minus here, which is good. And then you got 12x squared and 243. Well, you might say to yourself, well, 12x squared, that's not a perfect square. So there's really nothing that I can do. However, we need to look to see if we take out a common factor. So if we look at these right here, 12 and 243, what number can we take out that will a common factor with, for this problem so that hopefully we can get these two numbers to be perfect squares? Well, if I take out a 3, that would leave me with 4x squared. And then if I take out a 3 here, so basically 3 times what gives me 243 would be 81. So now when you look, this 4x squared is a perfect square, and 81 is a perfect square, so we're good. And again, like I did in the other lesson, circle your common factor, drop the arrow down. You don't want to forget to include that in your end problem, the final product, because that's the only way you're going to get that complete factorization. So we take square root of 4x squared, which is 2x. We just did that in the previous problem, number 1. And then the square root of 81, which is 9. So now we can go ahead and use the pattern. So this is going to be 2x minus 9 times 2x plus 9. Sorry about that. Again, the order doesn't matter. And I got my arrow here, drop this down. So you have the complete factorization, 3 times 2x minus 9 times 2x plus 9. Again, if you multiply this out, you would get the same expression up here, the 12x squared minus 243. All right, let's look at number 3. So we go here, and there's no common factor. Just look at that real quickly. I don't have a common factor. This is a minus, so hopefully these are perfect squares, because if they're not, then we can't do anything else, but they will be. So we're going to go ahead and do square root of this. So that's going to be 4x squared. and then the square root of y to the fourth is y squared. So now we can go ahead and set it up into the pattern. So this is going to be 4x squared minus y squared times 4x squared plus y squared. And you're like, great, I got this done. But then you might look and say, wait a minute, I'm not finished yet. Well, hopefully you recognize that. And why is that the case? Well, if you look at this right here, 4x squared minus y squared, that's still the difference of squares. So in this problem, we have to do the difference of squares twice in order to get the complete factorization. A lot of students will stop here and they don't completely factor the problem. So you want to make sure you double check. Obviously with the plus, you don't have to worry about it because there's no such thing as the sum of squares. But here, you say, all right, well, let me look. This 4x squared, that is a perfect square. Square root of 4x squared is 2x, and the square root of y squared is y. So drop, make sure you put an arrow here. You don't want to forget this also. And then we're going to put this in that special pattern again. So it's going to wind up being 2x plus y times 2x minus y, and then our other factor, which is 4x squared plus y squared. That is the complete factorization. Okay, well, hopefully you enjoyed this lesson. You can see my other lessons on my YouTube channel at Polynomials Math. And like my first period used to tell me, make smart choices. See you next time.